Okay, so for the presentation today, what we're going to look at is we'll take a look at the analyzer, of course. We've covered this multiple times throughout the course of our previous webinars, but just to recap, how the analyzer works, the technology itself, and the technology in which it's based upon, the key advantages of the analyzer, and how are we different when compared to other technologies that are available. And as Mike mentioned, the key new information that we want to highlight today is just a bit more info on the sampling, how we handle monitoring and continuous monitoring within the activated sludge. And then, of course, we'll touch on some applications and how some of our customers are getting value from the data and the use of our analyzers within their wastewater treatment facilities. So the analyzers themselves and the technology in which they're based upon, they use or they employ rapid ion chromatography combined with our patented UV LED detection system. And that ultimately enables simultaneous selective detection of nitrate and nitrite in situ. In terms of analytical performance, we really seek to deliver lab quality performance in the field. So we expect greater than 95% accuracy in situ, and that goes for in situ within wastewater applications, of course, as well. We also have the analyzer technology is also accredited to ISO 14034, which again just highlights the performance of the system. Fluidically, and how the system operates, this is going to be, keep this in mind when we discuss the settlement system or the pre-treatment system that we'll discuss now in a couple of slides. But within the analyzer, the fluidics themselves, the inlet and outlet of the system, they're submerged within the sample that we're analyzing. There's a small pump internally within the analyzer. The pump pulls the sample through the system. It fills an internal reservoir within the system, and then a sample intake syringe pulls a sample aliquot from that reservoir. It fills a sample loop of a fixed volume. Our mobile phase then, which is driven by syringe, it's a syringe delivery system, but the mobile phase then passes through the 6-way valve. The fixed sample volume is injected into the mobile phase. Everything passes through an anion exchange column, and then it passes into our UV LED detection system. And in terms of the LED that we operate, it's a 235 nanometer LED, which basically enables us to achieve direct optical detection for nitrite and nitrate. So that's what's happening within the system. Why is it different, or why bother? Why are we doing it this way? The key value from the system, it's all to do with the separation through that ion chromatography combined with the selectivity of the UV LED detection system. So when you're looking at other available technologies, UV probe technologies, which have been around for a long, long time, all UV devices, they use algorithms or matrix-specific calibrations for nitrite and nitrate. But there's challenges associated with that. Turbidity is a big issue. The presence of organics, bromide, other UV-absorbing species, they can cause interfering effects, especially within the wastewater treatment application. And as you can see from the UV absorption spectrum here, the issue when considering quantification of nitrite and nitrate, the UV absorption, they overlap. The wavelength is very similar, so it's quite challenging to discriminate between nitrite and nitrate, especially when you're in wastewater applications, where there's potential for many other interferences. On the chromatogram here, which you see on the right, that's really why our system is different. We separate both nitrite and nitrate, and we achieve selective direct optical detection for nitrite and nitrate. So that's really where it's different. In terms of analytical range then, for both NO3 and NO2, 0.6 to 500 milligrams per liter as NO3 and 0.05 to 100 milligrams per liter as NO2. So a very broad range. We configure the system based on the customer's application. So if we're going into drinking water, of course, we configure it with a larger sample loop, and vice versa. Then if we're going into wastewater, highly polluted waters, we configure it with a smaller loop. So it basically, it's tailored. The configuration is tailored for the application, but it's a very straightforward configuration. I won't labor too much on this, but this is just an example of some performance verification that we've done over the years with Scottish Water, US EPA, other organizations as well. But this is essentially the ISO accreditation which we've achieved for the analyzer technology. And as I mentioned, over 95% accuracy is what we expect, plus or minus 5% on the precision. So really just a high-level summary of what I just mentioned there in terms of the differences. The ion separation combined with the UV LED detection, that enables our selective detection for nitrite and nitrate. The calibration is carried out in factory here, so there's no need for the customer to calibrate on site, which is a big advantage. Another key advantage, especially when we're talking about quantification of NO2 and NO3 in wastewater applications, because we have that separation, we can quantify low levels of NO3 even in the presence of enormous levels of we can quantify low levels of NO2 even in the presence of very high levels of NO3. So that's a difficult thing to do if you didn't have that separation. And then another big advantage is the analyzer is sample matrix independent. So the system can be deployed within a freshwater application, and you can move the system into a completely different matrix, and you don't need to recalibrate. So we can go from freshwater all the way to fully saline, and you don't need to recalibrate the system. So that's a big unique advantage also. So that's the analyzer itself, and now that brings us on to the sampling and the pre-treatment system that we use to monitor continuously within aeration systems and other activated sludge processes. So the product itself is called Settler Monitrix, and it's designed to be combined with our analyzer technologies. And in terms of how it operates and how it works, so to the top right, you can see, top left, you can see the configuration of the Settler system combined with an Aquamonitrix analyzer. Fluidically, what's happening is shown underneath, but the key events or the key things that are happening within the system really takes place within the tubular setup highlighted in red there with the red circle. So what happens is a peristaltic pump pulls the aeration tank sample into the system. It fills the container, and the steps of events are captured here 1 through 8. So in picture 1 here, you can see that the intake filter of the analyzer is located in the internal tube. That's just an air at the moment. So the sample is drawn into the system. The activated sludge then is filled into the external tube, and there's an air bleed valve located within the fluidics, and that's closed at this point. So the internal tube in which the intake filter of the system is located within that internal tube, but that's separated from the aeration tank sample because of the air bleed valve is closed. So you can see the aeration tank sample is filled into the external tube. You can see it's settling in photograph 3. In photograph 4, it's beginning to settle. Then at photograph 5, you can see that the external tube now is full of supernatant. The solids have been removed. In photograph 6, the air bleed valve now opens, and you can see the internal tube, which has the intake filter located within it. You can see that start to fill. And then in photograph 7, you can see the intake filter is now submerged with the supernatant. At that point, the analyzer draws that sample into the system for analysis. After that analysis, everything then just a valve at the end of the tank opens, and everything empties into the aeration tank again. So that's the event, the stepwise sequence in terms of what's happening within the system. The total sampling time then is approximately 4 minutes from drawing sample in to analysis. So that's an overview of how we do it in terms of getting the sample from the aeration tank into the analyzer. So what that enables then really is it allows for us to generate reliable data from activated sludge processes. In terms of the analyzer itself, it's the only device that can selectively and directly measure nitrite and nitrate in activated sludge processes. And of course, the settler provides reliable, clean sample, as we've seen, because we're monitoring that supernatant. And ultimately, that delivers or enables continuous, remotely accessible data, which is shown here, for example, via our Data Monitrix IoT platform, but of course, all the physical communication options are available as well. In terms of some applications then, and where the systems are being used, so just to highlight some examples in terms of where customers are using the real-time data. As nitrite is a risk indicator for nitrous oxide emissions, some customers are using the real-time nitrite and nitrate data from their aeration tank processes to inform the potential for nitrous oxide formation. So it's early doors in terms of establishing that link from a process control perspective, but we do have customers that are very interested. They're working on that, and they're using that nitrite data to inform the potential and to establish potential mitigation strategies for N2O emission reduction. In terms of energy efficiency then as well, of course, continuous nitrite concentrations are being monitored, and that data is being used as an additional variable for real-time control. So some customers are using the technology for that. And then denitrification as well, which is, I guess, is a more clear application in terms of having that real-time nitrite and nitrate information. You understand where your the status of your denitrification process. So that's the analyzer is being used for that type of application as well. And then in terms of a very straightforward application, total nitrogen monitoring, towards total nitrogen monitoring, customers are using the analyzer for nitrite and nitrate data within their final effluents in terms of discharge and things like that. So just to highlight the data then itself, this is an example of deployment in the UK where the analyzer has been installed, monitoring the ASP for nitrite and nitrate. This data set here is 52 weeks continuous data. Interesting diurnal variations shown on NO2, and really the customer is pulling this data into their real-time control to see if they can optimize the process further. But it's just two more variables pulled into their process control setup. And then this is an interesting one which was raised by a customer. Actually, a couple of customers have raised it, but this particular example is the analyzer was attached to a commercially available membrane-based filter system for continuous monitoring in an aeration tank. And as you can see here on the top data trace, the nitrite levels were very low for a considerable amount of time, but then they cleaned the filter membrane and they observed a significant increase in ammonium concentration after cleaning, but they also observed a higher nitrite concentration consistently after the cleaning of the filter membrane, which suggests that nitrite conversion was taking place in the filter membrane during the course of the deployment. So again, it highlights the potential for filter membrane systems to act as biofilters potentially. So it was just it was an interesting observation. The customer raised it with us a couple of weeks ago. We thought it'd be interesting to highlight here. But again, at a minimum, it just shows the importance of cleaning filter membrane systems quite frequently. And then finally, this is a deployment post aeration tank, but it's a denitrification process. This facility had their aeration tanks, but then they had significant denitrification process tanks post aeration, and our analyzers were installed within this facility in France. The data itself is shown here. They're using this for a number of different reasons. One, to ensure that their emission levels for nitrite and nitrate are low and where they need to be from a legislation point of view. Very important, of course, now with the Olympics coming online now in Paris. But in addition to that as well, by having this real-time data, they're looking to improve their process control from a carbon source addition. They're adding methanol within their denitrification process. So by having this real-time accurate nitrite and nitrate data, they can optimize that addition of methanol. So they're using the data for this purpose also. And finally, then just wanted to highlight, this data was independently generated by the customer. So they just wanted to ensure the accuracy of the system, and they carried out an ISO 16489 test procedure on this over a number of months. But ultimately, they're just establishing the relationship between the aquamonitrix data versus accredited lab-based data. And as you can see, very strong correlation between the real-time data and the lab-based data, once again highlighting the analytical performance of our systems. So to conclude then, really just to summarize what we've discussed, continuous monitoring from activated sludge processes can be enabled, and it is enabled using our automated settlement-based pre-treatment system combined with our aquamonitrix analyzers. Now we can enable continuous nitrite and nitrate data, which is accurate across the entire wastewater treatment cycle. So there's a whole range of different applications, but also value that we can deliver across the entire wastewater treatment cycle. And then, of course, lab quality and analytical performance is what we aim for within the field through the use of our analyzers. So, as always, welcome any questions, and please feel free to get in contact after if you have any more detailed questions or you'd like to discuss anything. Thanks.
Okay, thank you very much, Eoin. We do have a couple of questions that have come through in the Q&A. One of them is to do with the settling device. So somebody's asking, what do you do if the sludge has different settleability? You said there was a process time of 4 minutes there. Is that something that's fixed?
Yeah, that's a great point. So you might have noticed I had approximately 4 minutes. So the default setting on the configuration is 4 minutes, but you're absolutely right. It's dependent upon the application. We can change that depending on the settleability. So we have some customers that operated at 6 minutes, others at 4, etc. But it's dependent on the settleability. And what's nice about it, it's all visually you can assess the settleability in terms of timings on install, so it's quite straightforward to do.
Turn my camera on and muted myself. There we go. How many times have we done that over the last 3 years? Just another question coming through on that final application on the denitrification. I couldn't. The question is around: was there any pre-treatment needed for that?
No, there wasn't actually. So it was post aeration, and the sample was to the point of a final effluent, really. But in terms of solids and all that type of thing, we didn't need to do any pre-treatment. It was just a direct install of the analyzer. And yeah, it was a straightforward application.
Okay, we have another question. Thank you very much, Peter, for your comments. Brilliant presentation. I agree. So there's a question here from Peter. A couple of questions actually. So we'll do the second one first, then we'll come to, and then we'll do another one. You'll see why in a minute. So do you know on the filter system? It's asking whether it was an MBR or MABR. I think that I can handle that one, Peter. What we're talking about there, the filter that we're talking about is a pre-treatment filter. Some of our clients have existing analyzers with cartridge membrane-based filter systems to present a sample. So we weren't so much talking about the wastewater treatment process being MBR or MABR. It was to do with it was just a straightforward activated sludge plant with diffuse air aeration, but the sample presented to our analyzer and other online analyzers came through a filter. So there's a cartridge filter immersed under the effluent. You pull the water through at pressure and remove all the solids and deliver a clean sample. And we saw that affecting the readings. And we'd heard that before from a couple of clients that they thought it was a possibility, not necessarily just with aquamonitrix, but with other systems they were using on site. And we have a couple of data sets now, which absolutely definitely show that if you leave these pre-treatment systems too long between cleaning, it definitely affects the reading. We have got installations on MBRs and MABRs, but that's probably if you wanted to dig into that in a bit more detail, feel free to send an email to Eoin or myself, and we'll do that. And then the other one, which is a great question for the head of R&D: does the analyzer have an option to add ammonia?
Yes,
Interesting, because we are all familiar with the drift in other systems, about which we could not comment, of course, but if you can handle that, Eoin.
Yeah, no, again, that's something we've been working on for many years now. The goal is to have something available this year, but of course with all developments, it's there's no certainty right now, but we're working through our development cycle, and we're currently in the process of deploying and demonstrating on site. But absolutely, the ambition is to have nitrite, nitrate, and ammonia within a single system. Very important system, and we're working hard to deliver that, most certainly.
Yeah, and just to add to that, one of the strategic reasons we see that is one is, yeah, we are familiar that other ways of measuring ammonia can give some. There are advantages and disadvantages, but certainly drift in wastewater applications can be an issue. And the other reason we're looking at this is with one eye on the Urban Wastewater Treatment Directive, adding stricter total N requirements for final effluent. So the ability to measure all of the forms of N, with the exception of the organic N. So we'll be able to measure ammonia, nitrite, nitrate, which in most cases in final effluent is 95% plus of the N that's around there. So there's an interesting application there from compliance point of view, as well as process monitoring. Let's have a look. I think there's let me just see, there's another question popped up, I think. All right, there we go. There's one in the chat. Let's have a quick look. Okay, yeah, we've done that. Well, in the absence of other questions, and with an eye on everybody's time, because we're just coming up to 10:25 now, just give another minute if anybody's got a question. Other than that, fantastic presentation from Eoin, and we will emphasize that the presentations are available to you'll be sent a link, so you'll be able to replay them. We've certainly got a number of people in North America who will be playing this later. We've got quite a large number of attendees who've signed up who will be playing this later in the day, but you can all do that as well. Questions that occur to you, fire them back to us on the details that you used to sign up, and we will be running another webinar in a month. We try to keep this always keep it topical. But also as well, suggestions for subject matter you'd like to hear about, we're happy to do that as well. Otherwise, you are part of our mailing system and you'll hear from us very shortly. So just remains to say, have a fantastic day, everybody, and thank you for attending, and we'll see you soon. Thanks very much to Eoin and for John to making it all happen. So we'll see you on the next one. Have a great day. Thank you very much.